Hello, I'm Dr. Malescu, and in this session, we're going to do a quick journey, crash course, urinary system, the highlights, what you should know. The first thing I'm going to go over, which is super important, let me just open up the screen and let's keep moving. The kidney. So the kidney has these structures called the renal pyramids. And the renal pyramids contain these nephrons. We have millions, we have 1 million nephrons in all of these renal pyramids. In between the renal pyramids, let me start my annotation. In between the renal pyramids, we have these renal columns, okay? And so the renal columns are basically in between these renal pyramids. The renal pyramids themselves have all of these nephrons. Okay, so the confusing part is how do we separate out the arterial system, the venous system, from the actual nephron system, because it's all interrelated. We have incoming blood that is unfiltered blood that has waste products that needs to move through the kidney. And then the filtered blood has to return back to the heart without the waste products. And that returns back to the heart via the inferior vena cava. What happens with the filtered material? That is the part that is the nephron's job, where we will build the actual filtrate, which moves through these nephron systems, eventually reaches these little ends here called the renal papillae, which then moves into the little tiny areas here called minor calyx. The minor calyx merges into the major calyx right here, and then into the ureters, 2 ureters, right? Leading to 1 bladder, urinary bladder, to the urethra and out to the toilet. So let me mark this down. These are called the minor calyx. And then we get into the major calyx. And then the next step is the renal pelvis. So hard to spell it out here with my pen. And then finally, it goes out the ureter. So what goes out? That's the urine. So we need to go over the parts of the nephron first, and then we're going to understand how the blood comes in and how it gets filtered with all of these nephrons. All right, so let me clear all this and show you that the first portion of the nephron is called the glomerular capsule right here. Think of it as a coffee filter. It filters and it's going to pick up the waste. All right. These in here represent the capillaries. It is called the glomerulus, which already is highlighted here, but that's the glomerulus. And the glomerulus is a capsule. Whoops, I didn't mean to do that. Okay, the glomerulus is a filtering device within this capsule. This capsule is also called Bowman's capsule or glomerular capsule. The filtrate, okay, is going to continue into the proximal convoluted tubule. So we call this short for PCT. And then from there, it goes down the descending limb of the loop of Henle, up the ascending loop of Henle, okay? And so the filtrate, as it moves along, certain things are going to be reabsorbed, certain things are going to be secreted. We're going to talk about that in a minute. But first, I want to show you the path of the filtrate, which is not yet urine. So the filtrate moves through the proximal convoluted tubule, down the descending loop of Henle, up the ascending loop of Henle, and then from there, it goes to the distal convoluted tubule to the collecting duct. And by this point here is where the last portion of the fluid is reabsorbed into the filtrate and is going to be secreted out. So 99% of your water is going to be reabsorbed. But 1% is going to be secreted out in the urine. So now we're going to form urine so that it's going to go out in the renal papilla, which is located at the tip of this renal pelvis, into the minor calyx, major calyx, renal pelvis, and ureter. So the flow chart goes as such. Let me clear all the annotations. So we have filtrate forms in the glomerular capsule, or Bowman's capsule, has two names. From Bowman's capsule, it goes to the PCT, which then it goes to the descending loop, descending limb, ascending limb, and then that's the loop of Henle. From there, it goes to the DCT, then to the collecting duct, then to the renal papilla, then to the minor calyx, then to the major calyx, then to the renal pelvis right here, ureter, bladder, running out of space, urethra, and out into the toilet. Okay, so that's the path. I know it's a lot to remember, but now we're going to add on top of that understanding the blood flow. How does it come in and how does it come out? Because the blood gets filtered, but obviously we're not getting rid of all that. We're just getting rid of the waste product. So where does the blood go? So that's the next step is, let me clear all the annotations here and go on to the next slide, which I'm having trouble. There. Okay, here we go. So now, let me move this over here. This part is going to show you the blood supply. So let me use my annotation again. And we're going to say that the blood, I'm going to draw the heart here. The blood is leaving the aorta, the aortic arch and the aorta. And then we have the renal artery, which splits into segmental. And then from there, it goes to the actual interlobar artery, which is located in those lobes between the pyramids. So that would represent in here, interlobar. All right, interlobar. Then we have arcuate here. Then it splits up into corticoradiate like the sun rays. It spreads out across all of the renal cortex. And that corticoradiate will feed into each and every single nephron system. So corticoradiate is finally going to split up into the tiny afferent arterial, which now enters the nephron system. And so the afferent arterial is going to feed into the actual glomerulus, which then leaves the glomerulus via the efferent arterial. And we're going to see that efferent arterial leaving, and it's going to become the efferent arterial, From there, the blood is going to empty out into the peritubular capillaries. And that represents over here, you're going to see peritubular capillaries around the proximal convoluted tubule and the vasa recta around the loop of Henle. So I'm going to write that out. Efferent arterial, pardon me, peritubular capillary. From there, it goes into what we call the vasa recta. And then it does the reverse, meaning it's going into the cortico-radiate vein. And from the cortico-radiate vein, the blood without the waste is going to go into the arcuate vein. And I'd like to make a distinction. The vein does not have an interlobar. It immediately goes into the segmental. And then from there becomes the renal vein. From there, it becomes the inferior vena cava that comes back into the right side of the heart, right atrium. So that's the blood flow. So as the blood flows, the filtrate is moving through the glomerular capsule, the proximal convoluted tubule, the loop of Henle descending, ascending, the distal convoluted tubule, the collecting duct, the renal papilla, the renal, the minor calyx, major calyx, renal pelvis. And then we go on to the ureters. From the ureters, we start into flowing that urine into the bladder, and from the bladder to the urethra. So it is a lot to know. So let me clear all the drawings and clear out the annotation and move on to the next slide. So let me go do that. And here we go. So what you are looking at, first, I'm going to describe everything here. So remember what I said from the renal artery. Whoops, I didn't want to do that. Let me go back. Let me go back. Sorry. All right, so where were we? Right here. I accidentally pressed the wrong button. So we were right here. We finished doing this, and I am going to show you now. Annotate. Here we go. So from the renal artery, as I mentioned, and I'm going to show you with my model now, because that's going to help you a lot. So I'm going to go full screen mode just for a second and show you that you have the renal artery, which splits up into segmental here. Let me use my pen here, my virtual pen. See that renal artery? It splits into segmental. So it goes to each and every segment. And then you can see the lobes. These are the pyramids, but in between the pyramids are the lobes, and in between the pyramids are the lobes with the interlobar artery, as you can see here. Okay, so interlobar artery, as you can see there. Now, interlobar artery is going to feed into the arcuate right there, arcuate into cortical radiate, okay, like the sun rays. And then that feeds into the nephron system. So the nephron system, let me stand up so I can show you. The nephron system looks like this. And basically what you have is the incoming afferent arterial feeding into from the cortico-radiate. So cortico-radiate into the afferent arterial into the actual glomerulus. Okay, so let me go over that. On the image, let me show you. I got to take my Apple Watch off because it is causing me havoc as I'm working here. All right, so here we go. So what we're going to do is divide it up into a flow chart. So renal artery into segmental. From segmental, it goes into interlobar. From interlobar, it goes into arcuate. So I'm giving you all the branches. Arcuate artery then splits into smaller arteries, very tiny ones called corticoradiate. And that is the feeding one. Corticoradiate will feed the afferent arterial right here. So that's the next step. So from corticoradiate artery, all those rays of sunshine across the renal cortex, think of it as rays of sunshine. All those branches corticoradiate, they're all going to branch into each individual afferent arterial. And so the afferent arterial is going to feed into the glomerulus, so that this unfiltered blood with waste product is going into the first part of filtration process, which is right here in the glomerulus, where pretty much a lot of reabsorption and removal of waste product takes place. And we're going to reabsorb at the proximal convoluted tubule, but we're filtering. We're going to reabsorb 68 to 70% of what's done here. So the glomerulus is a very strong filter. So we're filtering out the waste product. So where is this waste product going? Into this Bowman's capsule or glomerular capsule. But hold that thought. Side note about that filtrate that's forming and going through the proximal convoluted tubule, Lupa-Henle, distal convoluted tubule, collecting duct, yada, yada, yada. We're talking about the blood flow. So let's finish up the blood flow. We have this filtered blood now in the glomerulus. Where does it leave? It leaves via the efferent arterial. So after the afferent, so you got 1, 2 segmental, 3 interlobar, 4 arcuate, 5 corticoradiate, 6 afferent arterial, 7 glomerulus capillary, 8 efferent arterial, 9, as you can see here, but unlabeled, you see these vessels? That's called the vasa recta. So that's 9. And 10 rolling around in the distal convoluted tubule. What are we going to have? It's going to be a vein now. So we're going to send this filtered blood via the corticoradiate vein, which you can't, it's unlabeled here, but that's corticoradiate vein. And from corticoradiate vein, we're going to go to, remember, the sun rays, but now we're reversing it, coming back, flowing back to the inferior vena cava. So corticoradiate veins, you've got that arcuate. Think of an arch over that base of the renal pyramid, right? So the base of the renal pyramid had the arcuate artery. And now we're talking about the arcuate vein, right? So now from the corticoradiate vein, we got the arcuate vein. From the arcuate vein, we do not have an interlobar, so no interlobar. Instead, it goes straight to segmental. All right, so the segmental is located pretty much, very much close in proximity to the renal vein. So this would be segmental vein right here, and that would be segmental artery, as you can see. Okay, so segmental vein to renal vein to inferior vena cava and back to the heart, right side of the heart via the inferior vena cava. Okay, so now let me clear, that was discussing all the blood flow. So let me recap, and then we're going to go and discuss the nephron system, what happens to that step 2 over here, because step 1 is bringing the blood flow into the glomerulus, but you know, what happens with that filtrate that's formed. We're going to shelf that for a second because I'm going to recap the blood flow in and out of the nephron system, okay? And it's coming from the heart, right? So coming from the heart via the aorta splits and gives off the branch renal artery, which then splits into segmental artery. And I actually have a dance to do, and I'm going to show it to you. So you've got the aorta. So, you know, all those cheerleaders out there, you've got the aorta 95 south, and then the aorta splits up into renal artery left and right, right? So renal artery left and right. And then we've got this dance going, segmental. So segmental means it is breaking up into segments across that the renal pyramids. And then it goes in between. So remember ballet, remember the interlobar artery goes in between the renal pyramids, which kind of look like columns, right? So that's why we have the interlobar artery. And then from there, we have the arcuate creating a crown. Okay, so that's the arcuate artery. And then we spread our rays of sunshine, that's cortical radiate. And then cortical radiate is finally going to come in, kind of like curvy in, and that's afferent arterial. And then we're going to have a ball of capillaries, that's the glomerulus. Then the blood exits, again, very curvy out, efferent. And then we have the vasa recta, which is around the loop of Henle. And then after that, the blood flows into the venous system, cortical radiate vein, arcuate vein, no interlobar, instead straight up segmental, which feeds into the left and right renal vein, and then up the inferior vena cava back to the right side of the heart. Okay, so if sign language helps you, body language, dancing, whatever floats your boat, but you do have to know the blood flow in and out of the kidney. All right, so now I'm going to erase all this and go on to, well, meanwhile, just like when we talked about the heart, simultaneous things are happening at the same time. We have formed filtrates around the glomerular capsule, yes? So now what? Now that filtrate is going to go into the proximal convoluted tubule, and it's numbered here. Pretty much 68 to 70% of that filtrate is going to be fluid that has necessary electrolytes and solutes that need to be reabsorbed back into the system. So that's what happens because this is such a strong filter. 68 to 70% of the solutes are reabsorbed back into the systemic circulation. All right, so it goes back into the peritubular capillaries. From there, the filtrate moves down into the second part, which is the loop of Henle. And from the loop of Henle, it's going to move into the distal convoluted tubule. From the distal convoluted tubule, it moves into the collecting duct. From the collecting duct, I'm going to draw it out right here. It's going to go into the renal papilla. So let me write it out, renal. And that's like the pointy part, all right, the apex of your pyramid, your renal pyramids. So your papilla, your renal papilla that empties out the urine is right there. So let me point right here, right there. Okay, here's another one right there. Renal papilla. Okay, so let's write that down. From the collecting duct, it goes to the renal papilla, which is an opening to literally secrete out and create micturition, secrete out the urine. So from the renal papilla, it's going to go to the minor calyx. Then it's going to go to the major calyx. Then it's going to go from there to the renal pelvis. From there, it's going to go into the ureters. From the ureters to the urinary bladder. To the urethra. And out. Okay, so that is that. So I do hope that you understand both the blood flow as well as how the filtrate is formed, how urine is formed, and the path of urine. So urine is formed from the unfiltered blood that's coming in via the afferent arteriole. The efferent arteriole is going to take out the filtered blood and bring it back into the system, venous system, back to the right side of the heart. Meanwhile, you've got that filtrate that's formed in the glomerular capsule that moves into the proximal convoluted tubule, moves into the loop Henle, distal convoluted tubule, into the collecting duct, and onwards it goes to, of course, the renal papilla, the pointy part of your renal pyramid. And then from there, minor calyx, major calyx, renal pelvis, ureter, bladder. Did I forget to write down the ureter? No, I didn't. It's right here. For ureters, urinary bladder, urethra, and out. Okay? So let me erase all the annotations here. And now we move on. And I'm trying to move on. Here we go. Okay, so to recap, these are the most important structures. These renal pyramids. Let me move back. These renal pyramids, I'm going to use red. These renal pyramids are filled with 1 million of these nephron systems. So let's kind of review again. We've got the renal artery, which splits up into, as you remember, segmental, interlobar, arcuate, which branches out into corticoradiate. Corticoradiate comes in as the afferent arteriole glomerulus, which is right here. Efferent arteriole, which is right here. Peritubular capillaries right here. Vasa recta right here around the loop Henle. From there, it feeds into the corticoradiate vein. From the corticoradiate vein, arcuate vein, segmental vein, renal vein, and then inferior vena cava back to the heart. So that's the blood flow. Okay, then what? Then we formed the filtrate in the proximal convoluted tubule, which then flows into the the filtrate is formed in the glomerular capsule, also known as Bowman's capsule. The filtrate then flows into the proximal convoluted tubule, descending loop Henle, ascending loop Henle, distal convoluted tubule, collecting duct, renal papilla, which is the pointy part of your renal pyramid, which I showed you on the model. Okay, and from the renal papilla into the minor calyx. Minor calyx are these structures right in here. Major calyx, let me just erase so I can show you just the major and minor calyx. So minor calyx is here. Major calyx is the section right here, and then the renal pelvis, and then the actual ureters, the bladder, and then the urethra. And that's how we get rid of our waste products. Okay, so now that we got that straight, I'll just keep going and show you a couple more images. If I can just get this done. We are stuck again. Let's see. There we go. All right, let me just move my image here. So now you can see that all the branches that lead from the, aorta, renal artery, segmental, interlobar, arcuate, corticoradiate. Then we go into the afferent arteriole feeding in to the glomerulus, which is going to be the exchange capillaries where we're filtering, and the filtrate is formed in the glomerular capsule. This filtered blood then leaves via the efferent arteriole, okay, which then moves, and the reabsorption, 68 to 70% of the filtrate in the proximal convoluted tubule gets reabsorbed at that peritubular capillary. Then we go down the descending loop of Henle, and we have the vasa recta around it, and the ascending loop of Henle, we have the vasa recta around it. So bottom line, that's where we get some more reabsorption taking place. And at this point, we are going to feed that filtered blood into the venous system via the cortical radiate vein, Archway Vein, no interlobar segmental vein, renal vein, inferior vena cava, back to the right side of the heart. Okay. Meanwhile, all your filtrate in the glomerulus is moving through the proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, distal convoluted tubule, collecting duct. From that, we have urine that leaves the renal papilla to the minor calyx, major calyx, renal pelvis, right? Ureters, bladder, and urethra. All right, so I do hope this helps you in terms of reviewing. Now, repetition is the way to success. So that's why in my videos, you're gonna see a lot of that. All right, so let's start with showing you what happens with filtration. So what are we doing here? So once we have formed filtrate, so the blood, the capillaries here, the glomerulus is filtering the blood, and we have filtrate right in here. This filtrate moves into the proximal convoluted tubule, and so we're going to reabsorb back into the peritubular capillaries. What are we reabsorbing back into the peritubular capillaries? Glucose, sodium, potassium, amino acids, calcium, magnesium, chloride, bicarbonate, water, vitamins, proteins, lactate, urea. Okay, so a lot, okay? 68 to 70% is going to be reabsorbed, okay? Now, what we're going to do is at this level, we're going to actually bring some into the filtrate. So what we want to get rid of is urea. We don't want a lot of hydrogen. We don't want a lot of ammonia. We don't want a lot of creatine and some drugs. So we're going to secrete it out back into the nephron system. Here you can see that water is reabsorbed at the descending loop of Henle. Water is reabsorbed into the vasa recta. If you recall, the vasa recta was that big network capillary system, right? So we've got the vasa recta clearing it all out, right? So clearing out the water that we need to reabsorb back into the system, right? We don't want to lose water. If we lose water, we lose blood volume and our blood pressure drops. So we need to reabsorb 99% of our water. So that's where we get it, at the descending loop of Henle. Here where we have a buildup of urea that's present still in the system, in the blood, in the unfiltered blood that still remains to be secreted, it's going to be secreted by taking it into the nephron system here. And what you're seeing is the last part of the filtrate is now going to reabsorb the sodium and potassium and chloride. You need to reabsorb that so that you have that osmotic pressure and you have fluid following back into the capillary system. From there, we get reabsorption again at the distal convoluted tubule, sodium, chloride, bicarbonate, and water. By the time we get to this section here, the collecting duct, our capillary system is going to get rid of or secrete the hydrogen into the filtrate, the potassium into the filtrate, and the ammonia. We don't want that in our blood. So hydrogen, potassium, ammonia is now going to be collected in the collecting duct. And any remaining water in the collecting duct that needs to be reabsorbed back into the circulation as that filtered blood back into the cortical radiate vein, leading it back to the heart. This is where it happens, all right, the last portion. And then finally, you have urine and it leaves via the renal papilla. So I do hope this makes sense to you all because it is super important to understand. All right, what's next? I think I'm done. So that is pretty much my presentation. I do hope that you enjoyed this journey. It's not by any means complete. What I'd like to show you now to end my session is actually sharing. Let me just see if I can do this full screen. Sharing my model here and showing you everything that I need to show you. And let me just get this to be full screen. New share. Let's see. I think this is the best I can do. Optimize. Okay. So what I'm going to do is unshare. Stop share. Pause share. And now I'm going to go to full screen, I hope. Let's see if I can work this out. I'm going to press escape and do this. Okay. So what you see here, you see the kidney. Oh, I'm reading it upside down. It's very hard because I'm trying to mirror you guys. So here's the kidney, and you can see basically the renal pelvis and the ureter. I wanted to show you the minor calyx. The minor calyx is closer to the renal papilla, which is right here. Okay, so these are the minor calyx. Major calyx, from there it leads into the renal papilla. Wanted to show you the renal columns. Okay, renal papilla, renal pyramid. There's the archway artery and archway vein, cortico-radiate artery and cortico-radiate vein. Okay, now here's the nephron system. If you want to look at the nephron system closely, I'm going to have to stand up to make sure that I can show it to you in the camera, but you can see the nephron system here. I'm going to try to do this with my virtual pen here. So there's the collecting duct. There's the glomerulus in the glomerular capsule, proximal convoluted tubule, descending and ascending loop of Henle, collecting duct, which leads to the papilla. All right. And then here's the glomerular capsule, Bowman's capsule, with the actual capillary glomerulus. And pretty much you can see the entry is going to be the afferent and the exit is going to be the efferent arterial. Okay. All right. I think that's everything that I have for you. I do hope you enjoyed the session with all my little technical glitches, but I hope you learned something. All right. Take care. Bye.